All right. Welcome, everybody. Thank you for joining us on this last day of build at a very early hour for developers. So my name is Daniel Gickelhorn. I am a program product manager with the Azure networking team. Today we're going to talk about networking proven practices for building world-class applications on Azure. A mix of what have we done thus far and a little bit as we go forward, sort of a glimpse into how are we sort of moving this platform forward to help build further and bigger world-class applications. Ooh, clicker. All right, so if you're building a world-class application, you need a plethora of different elements to build that kind of deep stack. And the goal that we have is that you basically are able to focus on building your application as best as possible and are able to use networking more as a way to build attribution to improve your application scalability, performance, and things like that. What we are, expect as building a world-class application is you're looking for a scalable and highly available application platform that can scale to your global audience. You're looking for end-to-end security so that as you scale your application out, you don't lose that ability to scale securely, safely, consistently. That you can achieve global performance wherever your users are around the world. And that you can use real-time insights and telemetry to be able to monitor, operate, and iterate on your application globally. So how do you do that? So there's three things we look at when we say building world-class applications. It is scaling your application out by looking at tiered offload of traffic, of attacks, of service overhead by using platforms in Azure. Using layered fault domains to be able to achieve high availability regardless of what the condition, either your app, some infrastructure, some broader global crisis that might cause some interruption to your application. And that you can bring content to the edge and cache it so that your global users can get it as performantly as possible wherever they are in any country worldwide. So we're going to look at that kind of broader infrastructure from kind of a tiered roadmap going from where you start building your single zone, single region application to being able to scale that out to a cross-zone application that's redundant to potentially a data center failure, scaling that out again to a cross-region application that is redundant across regions and more performant for your customers, and then eventually getting that to deploy globally so that you are as close as possible to your end user with all of that, your application content. We'll talk through how do you sort of attach to your application a broader platform with Application Gateway, start to scale that out across zones, regions, and eventually get to attaching CDN for that global footprint. Right now I'm going to hand it off to Amit, who's going to give you a overview of high availability load balancing architecture and talk you through the first of our set of demos.
Thanks, Daniel. Hello, my name is Amit Shrivastava. I'm a program manager with Azure Networking as well. So let me start by giving a sort of lay of the land. At this point, let's go with you have an application running on a virtual machine or a virtual machine scale set, and you are deployed in one region. Now, how do you scale that? How do you ensure that your traffic is equally distributed across all of your VMs? It's not lopsided to a single VM, and therefore, you require a load balancing. For load balancer, the Azure portfolio encompasses these three options. At Layer 4, we have what we call Azure Load Balancer. This operates for TCP, UDP, streaming kind of traffic. It's flow-based. When a request is coming, it looks at the 5 tuples. You can configure it to look at 3 or 2 tuples as well, but it looks at primarily at the 5 tuples, source IP, source port, destination IP, destination port, and the protocol. and it decides on that which backend VM to send the traffic to. Now, this is not a proxy. There is no VM running in between. It is completely built on our software-defined networking stack. It's massively scalable. It grows as you send more and more traffic to it. So it distributes that traffic within our infrastructure, and it's not a dedicated deployment. You can use it for cross-zonal traffic as well. I will cover that going forward. And it is available in external or internal load balancer forms. So you could use it for a public-facing load balancing, or also if you have configured, let's say, VPN or ExpressRoute, and you are trying to load balance an internal traffic from your on-premises, or within your virtual network, if you have multiple services which want to communicate to each other, you could do that. Going up a layer, you have layer 7 load balancer, which is called Application Gateway. Now, in contrast to Azure Load Balancer, this is a dedicated deployment. When you create an application gateway, we actually create instances of a fully managed service, which we manage, but it is injected into the customer's VNet, into your VNet, and it is dedicated to that particular VNet traffic. Now, this is a reverse proxy. It offers you SSL termination, a central place to offer security for your entire traffic, and it, again, is configurable as an external or an internal load balancer. Offers 99.95% SLA. Taking that one level further up, you have, at the DNS layer, we have something called Traffic Manager. Now, the job of Traffic Manager is to provide you what is the most optimal VIP for your traffic. So you are coming from North Europe, and you say, hey, I want to reach my service. You give it a CNAME. It will tell you which particular IP you should hit. And from then onwards, it's out of the picture, right? So it is at DNS layer. Again, this is an infrastructure component. There is no dedicated deployment. It's, again, built on our stack, and it provides 99.99% SLA. There are many flexible routing policies as well as nested profiles, which we will cover going forward. So that is a sort of overview of what is your load balancing choices. Now, all of these plug and play together. So you could use Traffic Manager at the DNS layer and integrate that with an application gateway or Azure Load Balancer at the regional layer. So that flexibility is available to you. Going forward, let's dig a little deeper into your layer 7 application gateway. So you require, if anytime you require your load distribution to be not just a flow-based, but something which wants to take advantage of layer 7 semantics. For example, you want to take load balancing decision based on URL path, or you have hosted multiple applications behind a single load balancer. For example, you might have hosted Contoso.com and Fabricam.com behind a single load balancer, and depending on the URL path which comes into the application gateway, you want to send it to backend pools. You require something at layer 7, right? Having a layer 7 load balancer also gives you an opportunity to do central certificate management. So all of your certificates for your 20 to 40 sites, which it supports today, can be offloaded at one central position. You don't have to configure those certificates on each of those backend VMs. You can have independently scalable backend pools. So for example, at Contoso.com, I have a path-based routing set over here, which is video and images traffic. Your video traffic, if it is heavier, then that backend pool can scale independent of your lighter static, let's say, images or a static content page. So it allows you all of those flexibilities. We also support redirection directly at the gateway. We support for platform integrated components like Azure Web Apps, virtual machine scale sets. All of these are integrated with App Gateway. So for example, if you have a virtual machine scale set as your backend pool, and based on your traffic pattern, your virtual machine scale set expands, then it sends a notification to the load balancer that, hey, I have 5 more instances added to the backend pool. And without you configuring anything, load balancer is now aware that I have, instead of 10, I have 15 instances where I can send these requests, and it load balances across. Similarly, if your VMSS contracts, it does the same, and it removes them from the backend pool. We support connection draining. So your backend, if any VM in your backend is taken off for rotation, it does not lose all the connections instantaneously. It is gracefully removed from the backend pool. Coming to security, since it is a central place, of course, you have configured SSL termination, you have configured cookie-based affinity, but we also just introduced something called SSL policy. Now, this gives you an opportunity to control how your traffic flows. So you can say my SSL policy is either a predefined or a custom policy. Predefined policies are the ones which we have come up from our discussion with our crypto board, and we find the best SSL policies, and you can use those. So it would say, here is a predefined policy, and if you choose that, we will only allow TLS 1.2 and not allow TLS 1.1. Not only that, you can also choose what cipher suites are available. So you can eliminate, if your corporate policy says that do not use a particular cipher. If you want only to use ECDSA kind of ciphers, elliptical ciphers, then you can do that with SSL policy as well. We also have something called end-to-end SSL. So most of the time, since this gateway is within a virtual network, the backend communication is over HTTP. But we do not limit you to the virtual network. We do not say that you can only communicate to instances which are within that virtual network. You can send traffic outside of Azure, for that matter. You can send traffic to your on-premises, which is connected with VPN. As long as there is IP connectivity, you can send traffic to that backend pool. So now that poses an interesting problem, that what if you have, for example, a web app, which is a public IP. So the traffic is going from application gateway and going out to a public IP. In that case, many customers want to re-encrypt the traffic. So we support that as well. So SSL is terminated on the gateway, and while going out of the VNet, it is re-encrypted. Continuing on the security of application gateway, we also offer Web Application Firewall at application gateway itself. So now you have configured SSL, you have configured SSL policy, and we take it one level further with a Web Application Firewall. Now, this is an easy to use, easy to configure firewall. I will show in demo how straightforward it is to configure with a few clicks. And it offers protection against most of the OWASP top 10 vulnerabilities. Most important of those are SQL injection and cross-site scripting, but there are many more rules. For example, remote file inclusion, local file inclusion, directory traversal, bots, or you are trying to do anything which is violating the protocol. So there are protocol violation attacks detected as well. We are fully integrated. The WAF is integrated with Azure Monitor as well as Azure Security Center. Security Center is our central platform for monitoring the health and security aspects of your applications. So if you configure the WAF through Security Center, you get alerts directly into the Security Center, which will show you what's happening with your application. Anytime we detect a vulnerability, it is sent in real time to our logging platform, and it is also sent to Azure Security Center. I will show that in a few minutes. Now, at this point, you have configured SSL, you have configured a Web Application Firewall, which protects you from layer 7 attacks. The next question becomes, how do I configure, control, and protect myself from a distributed denial of service attack? So on Azure, as a platform, there has been always a DDoS system which protects every public IP. We call it the basic DDoS. Very recently, in the last month, actually, we went GA with DDoS standard. This is a more customized DDoS offering. You configure it at a VNet layer. So on your VNet, you turn it on, and now all the public IPs within that VNet are protected by the DDoS standard. Now, the difference is that this is self-learning, self-tuning algorithm. It looks at your regular traffic pattern. It monitors and it watches what constitutes normal traffic pattern to your application. If there is a violation and if it starts seeing a traffic pattern which is very different from what it has learned, then it stops that traffic. And again, it is integrated with Azure Monitor, so you can see where, what kind of protection or mitigation it did in real time. So everything which is inside that virtual network is protected by the DDoS protection. Now, if you have an application gateway within that virtual network, now you have just protected your entry point into the application from DDoS attacks, WAF, and SSL. So that gives you a holistic picture. Let me show you in a demo things which I have talked about. So in the portal, I have set up a resource group which has the WAF setup. But let me start with how do you configure an application gateway or WAF. So you click on application gateways, and you start with, let's say, a name for the WAF. And here is the SKU. So you have two choices. You can do standard, which offers all of the capabilities I talked about, multi-site, URL-based routing, cookie affinity, SSL termination. Or you can choose WAF, which includes everything which is there in standard, but also adds a web application firewall. So you get both. So let's choose that. And you choose a SKU size and few instances. And let's create a new in a given region. And that is mostly the configuration section of it. Let's create it in a virtual network. So let's say I'll just create a new one. It shows all the virtual networks which are available to me, or you can choose to create a new one. And what is the front end? You can choose to be a public front end, public facing, or you can choose it to be a private, or you can choose both. So let's say public, and it requires a public IP at this point. And you can choose HTTP or HTTPS on that public endpoint. And here is the web application firewall configuration. That's all you need to do. Whether the firewall is enabled or disabled, you can turn it on or off. And we offer two modes on the firewall. It can run in detection mode, in which case it just observes the traffic and logs all violations. Or you can run it in protection mode, where it will actually send a 403 and deny the traffic. So you can choose that and click OK, and that is about it. And at this point, you are creating a web application firewall, and it is creating with a public IP with a few rules. Let's go back. I have one already configured here. Now, web application firewall section is enabled if you have chosen a WAF. And you can see that it is running on OS 3.0, the core rule set. And you can go into advanced rule configuration and switch on or off rules. You can say, hey, I want to, for example, go to DOS protection and turn off a few rules over here, and so on. So if you get false positives, you can turn off rules, and you can switch between enabled, disabled, or you can choose a different rule set. We offer 3.0 or 2.2.9 as well. So let's take a look at this. Here is my public IP. I just have these. So this particular WAF was deployed in North Europe region. So that's where you are seeing North Europe and instance 1 over here. And we can say that, OK, here is my test. Now, this is a very, very straightforward PHP application. This is probably the most insecure application you can build. And we can just submit a query. But if you try to do something which is not, for example, you are trying to do, trying to read the cookie, it detects it, and it throws an error straight away. You can see more things which it does. For example, if you are trying to access it, and it thinks that this is a bot-like behavior, then it detects that. And it would stop that kind of attack as well. So let's open a new bash window. And over here, I'm trying to send a user agent which we know is a known scraper. And if I try to send that traffic, it just detects that and stops that kind of a traffic. Let's say that I want to try and send a command injection. Again, it detects that you are trying to send it an RM minus RF kind of OS command injection, and it detects that and stops that kind of traffic. If you're trying to browse the directory, for example, it would detect that as well and stop you from going to that. So now, a WAF, you require these to also monitor these continuously. So we have configured that with metrics. And now it shows you all different types of metrics which are available to you. So you can see the total number of current connections, failed request, healthy, unhealthy instance count, and so on. But more importantly, this is also integrated with OMS log analytics. So if you see the settings over here, we have configured that to send the traffic to build 2018 OMS, right? So we can go into the monitor section and do log analytics on this. So all of these attacks which we have been doing, it triggers a log, and all of those logs are sent to OMS log analytics. So now at this point, I can go and search. So I'm saying, give me Azure Diagnostics, look at my Application Gateway Firewall logs, and give me for build 2018 WAF1, show me all the errors which it generated. So it shows all of the 482 errors at this point, right? Now you can do more sophisticated queries if you wanted to do something like, hey, I want to see what are my top 5 requests which have been trying to hit me, with details of those requests. Here are the top 5 kind of requests which the WAF detected. Now, in interest of time, let me just go a little faster. We are also integrated with Security Center. So OMS lets you do all kinds of ad hoc queries. You can see, give me all 5 reports, give me all 5 most hitting client IPs which are trying to hit me, right? All of that report is sent to Log Analytics, and it is also sent to Security Center. So Security Center would load, and it would show you the same alerts as a visual graph. Right? Now here you see all of those protocol violations and all of those things set up as an alert. Now, in the Security Center. You can also set similar alerts on the Azure Monitor side as well, where I have set up an alert which is called WAF logs, which basically is saying that anytime a query is generated, which we have given it a custom query and say that if there is any WAF log emitted in the past 1 hour, then set an alert. So it is continuously looking at OMS log analytics queries. It is looking at how many alerts were fired, and if any time that count exceeds 1, it sends an alert, which I have configured through email. You can configure SMS alerts, you can configure email alerts, all through Azure Monitor. So that is something which you can do from there as well. Now, let's go back to our presentation. So at this point, you saw that how quick and easy it was to configure a web application firewall with just a few clicks. And without changing any code in your backend, you were able to protect that application from many different types of attacks, SQL injection, cross-site scripting, and you were able to set alerts on them, integrate that with Security Center, and do sophisticated ad hoc queries on them. So let's move it forward. At this point, you have configured an application which runs on a single region. How do you take it forward? How do you make it more resilient? You can use Azure. We just launched GA of Azure Zones. Now, these are logically independent data centers. These are physically and logically independent data centers within a region, which are isolated from each other. So any software or hardware failure in one zone does not affect anything on the second zone. So we have introduced that in a few Azure data centers, and more will come. Now, Azure Load Balancer is aware of zones. It is cross-zone capable. So you can set a layer 4 load balancer and put your application in multiple zones and route it through a single IP. Now, that IP is zone redundant. If there is a complete zone failure, even then that IP is up, and it will continue to route traffic to the remaining zones. So for example, if your application is in zone 1, 2, and 3, and you have set the zones, and there is a zone failure in zone 1, your IP and load balancer is still up and will continue to serve traffic to zone 2 and 3. Along with these, there are a lot of performance enhancements. With the standard load balancer, it is in general availability in all regions. In the regions where zones is supported, it is also cross-zone aware. So that is the next step you will take in your resiliency of your application. You want your application from regional to zonal resiliency. Let's go forward. How do you do that at layer 7? So far, the choice was that you would do application gateway in zone 1, another application gateway in zone 2 with something which we call zone pinning, and you use Traffic Manager. Now, Traffic Manager is monitoring these two zones, these two application gateways, and deciding which zone is up, which zone is down. And that's how customers could do layer 7 zonal availability. We have introduced a new enhancement to that, which I will cover. Since I talked about Traffic Manager, as I said, is our DNS layer. It can do different profiles. It can do performance-based profile, which routes you to the nearest geographical region. It can do much more. It can do nested profiles. So for example, you could say within a region, send 90% of traffic to endpoint 1 and send 10% of traffic to endpoint 2, and configure it that way. So that was that is a choice which you can take the next step from cross-zone to cross-region. You can take your application, which was zonal resilient, and now you have, from zone redundancy, you have made it into a cross-regional resiliency. On application gateway side, we are announcing a private preview of cross-zone application gateway capability. So very similar to the Azure load balancer, which had a zone redundant WIP. Now application gateway, which is a dedicated deployment, it creates a zone redundant WIP, and it creates instances which are spread across zones. So now you don't have to configure multiple application gateways in different zones. You create one application gateway which is distributed across these 3 zones. So if there was a zone failure, the WIP would still be up. The application gateway would detect that there is a zone failure, and it will redistribute those instances so that the same capacity is available in zone 2 and 3. It also supports static WIPs, and it also supports much more performant on number of SSL offloads it can do. So this is in private preview. You would have to sign up for that, and we will make it available in more and more regions going forward. So I have a quick demo. On this. So at this point, I have configured the same application, right? I have configured the same application at 2 different locations. This is on RG1 and this is RG2. These are in 2 different regions. RG1 is in North Europe, and RG2 everything is in East US2. Now I have also configured a Traffic Manager to distribute traffic across these 2, right? So if you see the Traffic Manager configuration, I have set that up in a performant mode. The portal is a little slow, but I have set up in performance mode, and it is looking at HTTPS endpoints of those two application gateways I showed you. So the same application is deployed behind the scenes, but it is now in North Europe as well as East US too. And you can see the endpoints. So there is one in North Europe and one in East US, and both are online. It is detecting that. Now, how do I hit that from a user standpoint? So I would just go here. Since it's a HTTPS, it's configured with a test certificate, that's why. But at this point, you can see that earlier when I showed you, this same application was showing me North Europe, because that's the endpoint I was hitting directly on Application Gateway. Now, if I'm coming from Traffic Manager, because we are in US, it detects that the nearest data center to me is actually in East US 2, and it sends me to this particular data center. And it is configured with a virtual machine scale set, so it is showing what VMSS instance is there as well. And you have the same basic functionality of the WAF. But at the same time, like, for example, if I had something which is here, I have another VM which is in actually North Europe. And if I try to do the same, if I try to hit from the North Europe VM, hit the same demo VA Traffic Manager website, then I should see something which is deployed in North Europe. So you can see that it is showing me an application which is running in North Europe. So using this kind of pattern, you can use Traffic Manager, and you can set multiple endpoints in global different data centers and distribute your application. I will hand it over to Daniel now to go over how do you take it to the next step with CDN.
Awesome. Thanks, Amit. This is great. Let me switch back to the slides. Number 5. And this logged out. So what I'm going to show you next is basically how do you take your app beyond just a regional approach or globally, or if your app happens to have some static content, how do you replicate that everywhere? That can be a dynamic page with short TTLs, like a news aggregator or site like that, or it could be just the images, JavaScripts, et cetera, that you want to be able to replicate so your users can load those faster from their closest location. Doing that, basically, you can take your application to the edge, so that's taking your application from your regional standpoint and attaching CDN, or a globally distributed content delivery network, to the front of it. You can increase application resiliency, because if the content's cached everywhere, then local failures, or even when you take your app down for maintenance, you don't have to worry about all that content cycling if your TTLs are long enough. It allows you to globally monitor all your regions and all your traffic coming in from a central location. Because everything's going through a consistent data plane on the CDN, it can show you basically how all your traffic is flowing globally. And it allows you to maintain end-to-end security by being able to attach HTTPS, a vanity domain, whatever domain you want at the edge, and offload again there, so you get more of that sort of tiered architecture. If you look at performance across delivering from a CDN versus delivering from a region, despite the fact that Microsoft has, or Azure has the most regions of any cloud provider, you can get even better performance by moving your content replicated to a CDN. Average edge latency in North America and Europe is between 25 and 30 milliseconds, whereas if you're going back to the data center, that's around 75 to 80 milliseconds round trip time for your customer. And that can have a material difference when you're looking at more expensive HTTPS calls and you have a lot of cold connections from an application, because it has to reestablish and do multiple round trips every time you do that. So you pay somewhere between 3 and 5 times that millisecond latency just as tax on the network if you're going all the way back to the data center. One thing that we announced on Monday is that in addition to your choices of Akamai or Verizon through Azure CDN, you can now use our own CDN, what's called Azure CDN from Microsoft, one of the providers in the Azure CDN portal, to be able to use infrastructure we've built over the last 5 years for our internal customers of Office and sort of big enterprise businesses that you can now use for your own use on Azure. That's in preview now. We launched it with 54 global metros, 16 regional caches, so that if you do have potentially a large traffic event, you can deal with that spike coming without it hitting your origin really strongly. And we added a feature that you can bring your own SSL certificate, so that if you have a requirement in your organization to be more compliant, manage your own cert, we'll basically allow you to upload anything you want onto the platform with some minor restrictions. So what I'm going to talk through in a really quick demo is how do you create an Azure CDN from Microsoft profile, how do you create a global endpoint for your application, how do you bind a custom domain name to that, and finally, how do you monitor your global traffic with core metrics on top of that. So quickly, creating a CDN is a really easy experience. You basically go to the portal, click Web, click CDN. It gives you basically some name, so we want to say build 2018 demo CDN. Created on any new resource group that you want. And any region. The region is more of an artifact of where do we store the configuration. It's global, but you have to put it somewhere. And then, as you can see, as of Monday, we have standard Microsoft at the bottom of the list. You can create a CDN endpoint. In this example, I'm basically going to take the same application that Amit created with Traffic Manager, so that you have a CDN in front and then you have resiliency on the back end, so that the CDN endpoint will go to the closest origin or application gateway that you've created via Traffic Manager. And during failover, it'll route around in case you have a outage in a given region or in a given zone. Oh, this is the wrong field. No. All right. So let's call it build demo 1.azureedge.net. This creates basically a CNAME for you. I'll talk about that in a second. And done. So at this point, we're deploying a global CDN profile in front of your application. As this goes deploys to production, it'll come live, and you can use that host name, bd1.azureedge.net, that we just created, to be able to hit it from everywhere. Now, if you're like me, I don't really like hitting something that's a random custom domain that Microsoft happened to provide you, so I generally have my own friendly domain names that I use for other products or on my website. And then you can go to, this is a CDN profile that I have created earlier. You can see that we've created an endpoint with that. That's the wrong one. And what we can do is basically add a custom domain name to this. So I have my friendly domain, globalcloudapp.net, which will load. And if you've ever managed DNS in Azure before, it's really super simple. I want to add a new zone. I basically add a record set, CNAME it to something that I've created before. So in build demo 1, I created this endpoint host name that says build-demo1.azureedge.net. That's really easy, basically, to CNAME to. You basically create a subdomain, so demo1.globalcloudapp.net, CNAMEs to alias build-demo1.azureedge.net. And at that point, you've told your DNS to point to your global CDN endpoint. You come to your, you take that same zone that we created, which would be demo1.globalcloudapp.net. If you come to your CDN profile, you can add a custom domain very quickly. demo1.globalcloudapp.net. This will go ahead and verify that you have a valid CNAME so that you can't just take some random Bloomberg.com or some other random name and associate it with your CDN profile. But at this point, you click Add. It deploys. You basically get your custom domain name everywhere. We also support with this being able to add a custom cert, or if you don't want to manage that cert, you can either provision one through Key Vault, and we can take a dependency on your cert in Key Vault so you can have it do auto rotation for you, or you can have us create a certificate and do all of that for you if you really don't want to touch the thing. So really quickly, since we're shy on time, in addition to that, you can use Core Analytics to be able to monitor your application globally. Core Analytics will give you information like how much data have you transferred, how many errors are you seeing from your origin to be able to detect issues or things like that, or if WAF rules are triggering, you'll be able to see that at a global scale in case, like you say, you're seeing some sort of bot or DDoS attack, and you can actually start to look at what is the user experience change in addition to the security violations and other impact you're seeing at application gateway layer. And finally, so that basically summarizes the tools you have at your disposal, some that are proven practices today and some that we've introduced recently to continue to make more and more what we call sort of proven practices going forward. What we did was we scaled out your HTTPS web application with Application Gateway, WAF, and talked about DDoS standard. We talked to you about how do you get 4 nines plus resiliency across zones, across regions, so that you're close to your customers, so that they are able to see your closest origin. And we talked about how do you do more with that, with that Amit talked about, about zone redundant application gateway that we have in preview right now. And how do you minimize user latency by putting your application on the edge with Azure CDN, including our new preview open right now, which if you want to go sign up, it's in the portal for Azure CDN from Microsoft. That's it. If you want more information on Zone Redundant Application Gateway Preview, there's a quick link for you there, as well as on CDN Preview, that's a link to our blog, but that one's in public preview, so you can just go sign up if you'd like. Amit's here, I'm here, at least one of us will be at the booth, maybe both of us from 10 to noon today. Feel free to reach out if you have questions, comments, etc. And we have a few minutes for questions if anybody wants to step up to, I think, the single mic in the middle of the room. Anybody? All right.
Hey, so for the Zone Redundant Application Gateway and for the global CDN, how are you getting the users to the closest Microsoft location? Is that through GeoDNS or Anycast or RumDNS?
That's a good question. It's technically all of those things. With Azure CDN by Microsoft, that's an Anycast-based product. It uses a little bit of a hybrid between raw Anycast and some other routing protocols. If you're talking about Traffic Manager, that uses a RUM-based DNS system with a GeoDNS overlay in case you have users in a location that are potentially, like sealed or otherwise not obviously visible from a RUM location.
Thanks.
Yeah. Any other questions? Good questions about building global apps or breaking global apps or attacking global apps? Key vulnerabilities in Application Gateway?
Hi. I've got one question. We are basically using web apps, so platform services.
Mm-hmm.
How could we benefit from this Web Application Firewall since there is nothing like VNet in our standard web app deployments?
You're good.
Yeah. So on Application Gateway, we introduce capability to attach directly to an Azure website. So there are a couple of parameters which there is a public documentation article.
Okay.
Essentially what happens is that when you hit, let's say from contoso.com, we used to forward contoso.com as is to the Azure websites in the backend. And that creates a chicken and egg story because that expects contoso.azurewebsites.net, and we were not rewriting the host at that point of time. So now we have natively integrated with Azure Web Apps. You can put a VNet, you can put a WAF in front, and then at the backend, you can say it is a Azure website. There are a couple of knobs, which is pick host name from the FQDN. So when the request comes in, it will see that I'm going to send it to these two Azure websites, which are called, let's say, 1 and 2. So whatever is incoming host name or incoming SNI header, when I'm going outside to the backend, I will rewrite the host name to 1.azure websites or 2.azure websites, and that works fine. So now you can put multiple websites behind a single CNAME, which is protected by WAF.
Okay, cool. Thanks.
Cool.
Sure.
All right. Any other questions? No? All right. Well, thank you, everybody, for coming. And feel free to grab Amit or myself afterwards if you have any other questions, or reach out via email or at the booth today. Thanks a lot.